All right, thank you, Josie. I'm going to talk a little bit beyond Florida as well, so we'll get into it. But this is a pretty high-level presentation. At the end, we'll get into a few weeds, but I think this is an important conversation to have because the topics we're going to talk about, my abstract, you can look at that later, is we're asking for a cultural change from engineering. We've been telling engineers for 50 years, keep the chlorides out of concrete. And now all of a sudden we're saying, well, you can put them in. And that's not an easy thing to convince an entire industry that is practical or even necessary. And so we all, perhaps in this room, can see the benefits, see the potential, but that message really needs to be conveyed convincingly, not in a marketing perspective, but giving the reasons why we should do this and how we have done it, and potentially what strategies we might consider moving forward to safely deploy seawater concrete technology. And so there's some work being done already here at ACI with the 243 committee and next. But I'm going to talk about a few tools that might be considered in the context more of transportation infrastructure and more specifically bridges. There's been significant amount of federal research dollars given to state DOTs to pursue research on different kinds of innovative technologies. There was a dedicated program in, that's up on the screen here, is the IBRC, Innovative Research Bridge and Construction Program. So that was essentially $228 million over 6 years, which is like $250 million in today's terms. And they looked at, I had to write some numbers down, 150 projects had FRP in them. There was like 80 with high-performance concrete, high-performance steel, corrosion-resistant reinforcement other than FRP. And then there was about 30 accelerated bridge construction projects. And some of you might be familiar with the ABC program that FHWA sort of sponsored shortly after the conclusion of this 2005-2006 series of projects. And so that got a lot of attention, but they sort of, I won't say they dropped the ball on FRP, but it sort of just languished. UHPC was part of that program. Again, there was an injection of research funding and deployment assistance through the FHWA EDC program. And so we're seeing the fruits of that now with quite a lot of broad adoption of UHPC technologies, the development of AASHTO and ACI design guides. Eventually will work to a code. And so the question is, how do you do that when you don't have these huge injections of cash that happen? And so there are guidance on what you should be doing, not necessarily how you fund it, through this report on the IBRC program to look at what was the effective technologies on the diffusion of those technologies, materials mostly, but some construction practices over time, and what were the lessons learned for what was effective and what wasn't. And so you can read later on the highlighted yellow stuff, or you can download the whole report if you're a little sleepy. And, oh, you got my earlier slide maybe. Yeah, okay, all right. They couldn't find my presentation this morning at the Speaker Center. I'm like, okay, so I uploaded a new one and tweaked it, but not shown here. But so we'll get to why would we want to do this? Well, why would we want to do this at Florida DOT? And so we have a mission statement, and part of that includes protection of prioritizing the environment and natural resources. Now, we're not pushing ahead with saltwater concrete necessarily, but in the context of water conservation and reduction in natural aggregate extraction from quarries and things, recycling of use of existing concrete, it makes a lot of sense under this mission statement. And there is a plethora of resources out there. I counted over 200 that we're quoting or referring to in the 243 guide that's under development. Some of those relate to life cycle cost analysis, and some of those relate to life cycle analysis, assessment. And so some of those are environmental, some of those are economic. So there are a couple of reasons, compelling reasons that why you might want to do this. But that message has to get across to who? Well, it has to get across to owners. It's got to get across to designers. They have to be convinced they want to do that. They don't want the liability that might be associated with something that doesn't have a codified design criteria. We have guides, but the way we implement guides is, as an owner, we specify you use this guide, and then that sort of shifts the liability off that designer. And so at this point, we don't tell them to use seawater concrete. We have prescriptive limits on the chloride content of the cement that goes into concrete mixes. We have prescriptive requirements on the percent of chlorides relative to the cement content. And so, similar to ACI, this is all sort of blended between AASHTO and ACI. And so for pre-stress, that has the most restrictive limits because the pre-stressing strand for steel is the most susceptible to degradation. And so we've had conversations recently with our state materials office about, well, we actually have more restrictive limits than ACI recommends, just because we don't trust people, I guess. And the question has now come back to me, is like, well, what do we do with those limits? And so the implementation is really founded on standards and specifications that you can point to that are endorsed by authoritative bodies, whether that's ACI, AASHTO, FIB, someone else. And so this is something I've been struggling with about. We've spent probably 10 years looking at seawater concrete. Now, in reality, I didn't know I was actually doing it, but Tony sort of added it to a project that we were working on that was deploying another innovation, and at that time that was FRP. And so in the bottom left there was the Innovation Program, which is a joint European FHWA program that looked specifically at seawater concrete, and the enabling technologies to be able to deploy that were FRP, reinforcement, and stainless steel. And so Polymie and Nolan looked at stainless, and we looked at FRP in Florida, and we provided University of Miami a bridge site to go and do some of this demonstration deployment. And so that was called CCON. At the same time, or actually just prior to that, there was I think a very important NCHRP report that came out that looked at, sort of following on from the IBRC program as well, what were the effective strategies or the steps if you really want to institutionalize change. This is because the whole goal of the NCHRP program is to do research, applied research, and get it implemented. And so they looked at, well, what works and what doesn't. And so I think there's 10 steps in there. I'm not going to bore you with them today, but we actually looked at that back in 2016 and created a roadmap and said we should be doing this, this, and this. And I don't know, something happened. And it's still out there, but we're sort of focused in on some specific goals right now. But one of the important parts of those steps are basically providing easy access to information, and so to do that, there are different venues, different media that you might use. It's not really marketing, but it has to be easily accessible and relatively quick, because everybody's busy and nobody wants to read a 10-page paper, let alone a 100-page report. But so we stole something from the AASHTO Innovation Implementation. No, what is it? AASHTO, AII. So not architects, but AASHTO Innovation Initiative. And so they have these fast fact sheets, which are maximum 2 pages. And so we borrowed that, and all of our early projects that were really related to innovative technologies, FRP, pre-stressing and reinforcing. We also have something there on stainless steel. And so these became really useful tools just to get the word out. And so someone would ask me, well, what's Florida doing? And we eventually built a website that hosted these, and we could point to those very quickly. Actually made my life a lot easier to be able to refer to that rather than retyping emails about what we've been doing for the last few years. And so those are good ideas and strategies that we borrowed and maybe improved a little bit from others. There's also this, I think it's from Minnesota? Yeah, the National Concrete Pavement Preservation Demonstration Program, and they splintered off a Bridge Partnership Preservation Initiative. That's what the BPP is on the bottom of the slide there. And so under that program, that sort of gave a venue for vendors with technologies that don't really fit in a nice box, and to be able to get endorsement from the owners, because it's a collaborative group with owners and producers and designers. And so there are rules and regulations about what can go on the program and how long it has to be there and reports and things. But these are strategies moving forward. I mean, no one's going to do this for seawater concrete because nobody's selling seawater. So that's not really a viable path for this technology necessarily. But I know there are some FRP products in there that program is hosting as well. And so these are deployment strategies that we're wrestling with, because we're doing this work because we think it makes sense, and so how do you effectively do that and make it, a lasting, not legacy, but program. So it's really a cultural program. So if I was to retire or get hit by a bus tomorrow, I'm not confident that a lot of this stuff would keep moving. So that's partly my fault for not training people underneath me, but I never supervised anybody for a long time, so I couldn't force anybody to do anything. But the bottom of that slide in the red box, something else extracted from the IBRC review, was focusing on the importance of standards and specifications. Pretty boring, I know, but it is essential that you can point to something authoritative and say, use this, or somebody, a contractor might propose an alternative material on a project, and they're like, well, what tells you that you can use that? And it might seem pretty obvious, but it really isn't in practice being executed. And so that's sort of the high level part of the talk. I'll dig down a little bit on, so when do we do this, specifically seawater concrete? Well, we've already done it a little bit in Florida, thanks to collaboration with the University of Miami and some other partners. And so we have pre-stressed piles, which is our logical choice for seawater concrete because they sit in seawater. And I don't know if we get to the point where we would routinely use this necessarily at a state level, but there has been some private projects where they didn't want to use pre-stressing necessarily, and so it's just reinforced GFRP. The reason why we put pre-stressing in piles mostly is when you drive them, you crack them pretty severely, and so reinforced piles don't really work very well. But you can have non-pre-stressed piles and drive them gently and really get an effective product in the end. And then if it's non-corrosive technology, then you're not so worried about cracking under service or pre-existing cracks, which, believe me, we have loads of pre-existing cracks on pre-stressed piles that we didn't know were there. Well, out of sight, out of mind generally is the case until something bad shows up. And so the point, I'm not trying to promote FRP necessarily, but I'm saying if you're going to use seawater in your concrete, then you're going to create a potential risk for something to happen. And if you have a reinforcing system that mitigates or obviates that risk, then that helps everybody sleep easier at night. And so under the innovative, what was it, the innovative IDOC project, there were some precast elements. There were some leftover components that were kindly donated to a contractor. They put on a private bridge. And so we've got some things scattered around the state that we're struggling to track the long-term performance, which is another part of innovation deployment, is having monitoring, and who pays for that, right? So drilling down on the IDOC project, there were, this has been documented in some published papers and a number of presentations, but we had precast piles, precast bent caps, precast decks, and those were all made with seawater out of the Bay of Biscayne, I think, in Miami. And then we had a follow-on project. Well, we had a parallel project that we were replacing a bridge in southeast Florida, and we had some seawalls that flared out from the end, and Tony offered us a couple of piles to use as a demonstration, so we were able to substitute the least critical piles on that wall, I would probably say, with seawater pre-stressed concrete piles, and so those will be monitored in the future, but with no dedicated funding. And so this seawater concrete was also used on the Halls River Bridge cap, and there'll be a more in-depth presentation on that at the end of this morning's session, I believe. But this slide brings up a point about the degradation of the concrete with seawater in it, that there is a slight long-term reduction in strength. And we need to acknowledge that and make that clear, because not competitive, but someone who's not necessarily endorsing this type of technology would potentially latch onto that and basically dismiss the use. And so, again, there are some details in cores versus cylinders that make things look worse than they really are. And then just closing out with the Halls River Bridge project, we have carbon bars, basalt bars, GFRB bars in seawater concrete that we have extracted at 9 months, 18 months, 7 years is the latest project. It's not quite published, but that's we're talking. And so here's an example of the construction through to an extraction after 7 years in the middle on the right there. It's difficult to pull out full-size bars that you want to test and do a full tension test, but we've done it a couple of times, and I think there's some valuable information that's being shared, and look forward to that report coming out. Again, to the question in the last presentation, degradation in the alkali. This was combined alkali and chlorides, and so typically, depending on the product, you may get 10 or even potentially 20% long term. And so our reduction factors in design, slightly different from ASHTO to ACI, but they're intended to account for that. And I think that's it.